Hi, welcome back. So we're in Chapter 3, Descriptive Analysis, to close on the conclusion of Bivariate Descriptive. Essentially, we started by exploring the powerful technique of univariate analysis. And in the univariate analysis, we assume having only one variable. Either the outcome of this variable can be in a continuous form or discrete form. And then we have seen how number of subject as a vector. And then we've looked at different technique when it comes to the univariate analysis. It was basically to study the distribution, the central tendency, and finally the dispersion. And then after that, we explored that by expanding to adding a new variable. The same exact thing, the variable end up as a vector. And then we moved to capture both variables, how they are behaving. And that was the study bivariate analysis, to capture an important things, and that is the relationship. And the relationship was captured in terms of the directionality, the magnitude, and also the dependency. And that's why we identified a covariance, and then from there we extracted a correlation. But beside that, we were also graphically able to capture and see. And the story started by understanding the bivariate analysis throughout the possible outcome each variable can take. We explored this matrix in a contingency format, where x1 could have been continuous or discrete, x2 could have been continuous or discrete. Now, based on this, we started by exploring if x1 was discrete and also x2 was discrete. We have looked at these possible ways of capturing this measurement, and all of this to capture the covariance and correlation. So we looked at the technique of a chi-square when the discrete are more than dichotomous. And then we looked at the odd ratio. If the matrix is 2 by 2, we also study effect size, and we saw bar graph. And also in the continuous case, when both variables were continuous, we've seen the percent correlation formula, also the Spearman's correlation formula. If it happens, the relationship is not linear. Also, we explored the power of a scatter plot to explore the real directionality. And then based on all of which, we were able to have a different kind of exploration of the covariance and correlation. Finally, when both are different, for example, discrete and the other is continuous, or continuous, the other is discrete, we've looked at point biserial correlation technique, and also we've seen the custom transformation technique. And also we explored another technique based on a graphical power by exploring the box plot. So that was everything that you need to understand the transformation from a univariate analysis perspective into the bivariate analysis perspective. Now we will expand this one more by showing you also in case of multivariate, the idea won't be very much different. Once you master actually the bivariate, the multivariate easier for you. The only things we can do with multivariate is to capture the graphing perspective, because when there are more than two axes, visualizing become a difficult things. That's why we will rely completely on the powerful of singular measurements such as the covariance and the correlation. After we finish this step, we will be ready then to start the last step of our analysis, and that is to test the hypothetical finding or the result that we are trying to propose from our analysis, whether they have happened by chance or they are actually a real representation of the population. So we'll see you then to explore multivariate analysis. I will see you then.